Lesson 3 is going to focus on some special properties when we multiply polynomials. So the first thing we're going to look at here is when we square a binomial. So there's two different cases. You would have, in this first one, a plus b. A and b can be any different numbers, variables. Um, but basically when you have a plus between them versus when you have a minus between them. So let's actually take a look at what does this actually mean. So the most common mistake is automatically students will want to square each individual term, but you really have to think of a plus b, the quantity squared, really means a plus b times a plus b. So as soon as you see a plus b, the entire thing being squared, you don't want to distribute that squared. You want to make sure that you think of it as a times or a plus b times a plus b. As soon as you see that, you're more likely to remember to either FOIL or to set up a box. So if I set up a box to do this, I have a plus b times a plus b. This first opening here, I'm going to have a squared. Then I'll have a times b. Then I'll have a times b again. And then I'll have b squared. And again, I have my like terms, so I end up with a squared plus 2ab plus b squared. And maybe you're seeing a pattern here where basically if you distributed the squared, you would have only had a squared and b squared, but we have to include this 2ab term. So this is a formula that you can use if you don't want to have to go through the whole process of foiling or using the rectangle here to do the a plus b times a plus b. The pattern is you can square this first term, square the second term, but then also do 2 times a and b, and that'll get you the entire answer. So that's another way of looking at it. Over here, if we had a minus, we want to see how does that change things. So let's look at this other piece where we have a minus b squared, which means a minus b times a minus b. So again, we're looking for a relationship between these or a pattern that we see. So I'm going to start off with drawing my rectangle. So I have a minus b, a minus b. Notice I'm keeping that minus sign, especially in this case, it's going to make a difference. So I have a squared when I multiply those. A times negative b is going to be minus ab, or negative 1 times ab. Same thing down here, I'm going to have negative times ab. And then the last term, negative b times negative b, is going to be a positive b squared. So again, combine your like terms, we get a squared minus 2ab plus b squared. And it's minus 2ab. So that's the only thing that changed. I'm still going to have an a squared, still going to have a b squared, but because of these minus signs in between a and b, it's going to result in a middle term of negative 2 times whatever a and b are. So you can use these special patterns or these formulas to make some things simpler, but you don't have to. So let me do an example where you go ahead and you do the method we used previously, and then I'll show you how to use these formulas. So if we look at example 5, this is just asking you to find 4x minus 6 quantity squared. So you have to remember that whenever you see this, this does not mean square each term. It really means 4x minus 6 times 4x minus 6. That's what squaring something means. It means multiply the quantity by itself. So then once you see that, you're more likely to remember that yes, this does have to have a box. So it's going to be 4x minus 6, 4x minus 6. And then again, we're going to go ahead and multiply to fill in this box. So 4x times 4x is going to be 16 because I multiply the numbers in front. Keep the base, add the exponents. The exponents here are 1, so it's just going to be added together. We get x squared. Then I have negative 6 times 4 is negative 24. Keep the x. Over here, I should get the same thing. So I have negative 24x when I multiply. And then lastly, I have negative 6 times negative 6 should be plus 36. Again, you can combine your like terms. So we have 16x squared minus 48x and then plus 36. So that's like the longer way of going about a problem like this, but it's absolutely fine if that way makes most sense to you, do it that way. Shortcut are using these formulas from up top. So since this was a minus in between the 4 and the 6, you would use this formula here. You would use the a squared minus 2ab plus b squared formula. And that's only because it's this entire thing being squared with a minus between it. So if you wanted to use that formula, well, a would have to be 4x. So this is using the formula. And this is like an or. You don't have to do it this way. So or using the formula. A would be 4x and b would be 6. And you don't keep the negative sign because the negative is going to be taken care of with this minus 2ab. So then I'm going to plug into the formula. So a minus b squared, this entire thing squared, is equal to a squared minus 2ab plus b squared. So I can go ahead and I can plug in. So I have 4x minus 6 squared is equal to, well, a squared is 4x squared minus 2 times a, which is 4x, times b, which is 6, plus b squared, which is 6. And you wouldn't have to show all of the substitution. I'm just showing you so you can see where I'm getting things from. And then I would just simplify. So I would get 16x squared minus, so I have 2 times 4 times 6. So I have 8 times 6, so I get 48. Keep the x plus 36. So that's just another way of getting the same answer. It's just showing you how you can use the special formula or the special property since it's the entire thing being squared. So let's try a couple just strictly using the formula so you get used to it. Again, you don't have to use the formula. It's totally fine for you just to say, okay, well, looking at this next example, x plus 7 times x plus 7, you could FOIL it, you could use the box. But using the formula, if I were to use the formula for this one, this is the a plus b squared equals a squared plus 2ab plus b squared. You don't have to write out this formula if you're using it. You can literally just take this expression and say, okay, what does it equal? So a in this expression is the x. B is going to be 7. So I could have just went right from x plus 7 squared to saying, well, I square the a term. I do 2 times the product of 7 and x. So it's going to be plus, because it's a plus here, 2 times 7x. So it's going to be 14x. And then I square the last term. So then you can see that that becomes much quicker if you don't actually go through and do all the substitution like I did in the previous one. But if you just kind of walk through it in your head, it does make it a little bit quicker of a process. If you look at the next one, here again I have that minus, so this is a minus b squared equals a squared minus 2ab plus b squared formula because of the minus. So notice the formulas are exactly the same except for when it's a plus. You have, so whenever it's a plus, you have a plus here. Whenever it's a minus here, you're going to have your minus in the formula. So it's easy to remember because it's just the same. You just have to remember whenever it's positive versus negative. So in this case, my A is my 3t, it's the entire thing. B is 5. We don't ever worry about the negatives or the positives because we take care of it when we do plus 2ab and minus 2ab. So then this here, becomes, well, you square the 3t, so that's going to be 9t squared because you had to square the 3 and the t. Then you do 2 times the product of these, so I have 2 times 5 times 3t. So I'm looking at 5 times 3 gives me 15, times 2 gives me 30, so it's going to be minus 30t. And then I have plus 5 squared, which is 25. And that's it for that. So that's, again, the shorter way is to just kind of walk through it. But if you need to write it out, you can. If you'd rather just do the box and not have to worry about this formula, that's totally fine too. Let's look at one other special property which you've heard of before. So let's go and look at this one. This is called the difference of two squares, or the difference of perfect squares. You've heard of it when we talk about factoring. We will get to factoring. But first thing we want to do is we want to just look at how can we use this difference of perfect squares formula to help us simplify some multiplication. So we're really just looking at some special cases here and looking for some shortcuts. If you choose not to use these shortcuts, that's totally fine. But basically, whenever you have two terms, so if I have x minus y times x plus y, do you ever see something like that where you have a minus and you have a plus and you have the same terms? So like notice how I have the x's are the same, I have two y's that are the same, and in between them I have opposite signs. So whenever this is the case, you have the same thing, but the only thing that's different are these signs, the minus and the plus. This is a difference of perfect squares situation, and the middle terms are going to cancel. So if you did the box and the diagonal is going to cancel, because what's going to happen is you're going to have a minus yx and a positive yx, and they're going to cancel. So really what ends up happening here is the only terms that you care about are the x's being multiplied, so you would get x squared, and the y's being multiplied. And because it's negative times positive, it's going to be negative y squared. So if you ever see this pattern, instead of having to go through and doing the whole box and combining like terms, you can just say, well, I know those middle terms are going to cancel because one's a minus and the other's a plus. So if you look, when I look at this example here, first of all, this is a typo. Fix this so that it's a y. And then when you're looking at that, I see that I have the exact same format. I have a y and a 5, y and a 5. The difference here is one's a negative and the other's a positive. So that means if you were to do this using a box, you're going to get your middle terms, or that diagonal that we've always circled. Those are going to cancel because you're going to have a minus 5y and a plus 5y. So they're really just going to end up canceling. So all I really care about here are the first two terms and the last two terms. So the shortcut here is just to recognize this pattern and see that y times y is going to give me y squared, and then negative 5 times 5 is going to give me minus 25. So we're just picking up patterns here to make things a little bit shorter. So that's it for that one. Now if you multiplied it all out, you would have just done more work, but you should have gotten the same answer. So it's not a big deal if you didn't see the pattern. If you look at the next one, I have the exact same expression. The only difference is the sign. I have a minus and I have a plus. So again, what that really means is I can just multiply the first terms. So I get 4a squared, and then multiply the last terms. It's going to be minus 9. And you don't have to worry about writing out the middle terms because we know they're going to cancel. C, we see again, same exact expression. The difference is the minus and the plus. So we can multiply the first terms. We get x to the fourth because we keep the base, add the exponents. And then we have positive 4 times negative 4 is going to give me negative 16. And lastly here, same format, positive versus minus. So we have x to the 6th because we keep the base, add the exponents. And then the last terms minus 4a squared. So again, it's just recognizing patterns to make things a little bit easier for you. If you don't recognize the patterns though, you can always stick with FOILing, distributing, or doing the box method.